Hey there, folks. Today I wanted to take advantage of a YouTube video to wrap up some lecture we did not get through last week. So, week 4, we were doing chapter 5, talking about the signaling model of education. And we didn't quite finish it. And so I want to get to it, wrap up the different kinds of signaling equilibria we can expect. Quick review of what we were talking about with all of that, and then talk about a little bit of the empirics of this idea of the signaling model and how it compares to the human capital model. So hopefully this is a little bit of a review of what we talked about in week 4, talking about the signaling model, and then a wrap up of what we didn't get a chance to talk about. So let's get into it. Okay, so we were talking about the signaling model of education, and this is in contrast to the human capital model that said that education is an investment in an individual, making them more productive. And so we're investing in human capital as opposed to physical capital, and by investing in that human, we're making them more efficient, making them more productive, and there's going to be a wage return associated with that because that additional productivity is going to make them more worthwhile, make them more valuable in the labor market. The signaling model is a little bit of an alternative to the human capital model, and it says it's not so much that education makes an individual a more productive worker, it's that education is a signal about which workers were already more productive. And so the motivation for the signaling model was this idea of information asymmetry, that an employer doesn't know as much about a worker's productivity as the worker does. And there are some fields in which worker productivity is harder to measure. We talked about this in class, this idea that the signaling model makes more sense in, say, an office job environment than it would in, say, a lumber yard where you can say, I've seen you do this much work per hour. So when it's difficult to observe productivity or it's expensive to observe productivity, employers might benefit from a signal, which is a malleable characteristic of a worker that provides underlying information about their productivity. And we'll get to the difference between a malleable characteristic and a not changeable characteristic at the very end here. So the signaling model says that there are two agents. There's workers and employers. Workers have different levels of productivity, and employers want to determine who's a high productivity worker, but they can't observe it. But they do have some beliefs about it. And so those beliefs are going to be important for the model. And we want to remember what we talked about when we reviewed the labor markets, that wages should be based on worker productivity. The marginal product of labor, the productivity of those workers, should determine those wages. And employers should be able to, if they can determine productivity, they're going to pay workers based on productivity. So if we have two types of workers, low productivity workers and high productivity workers, we can assume that they have different levels of productivity. So type L workers produce 1 per minute and type H produce 2. We're also going to assume that the cost of education is a function of productivity. So the more productive worker can get through school faster or cheaper, and that the population is made up of just those two types of workers. So if P is the population of type L workers, then H workers make up 1 minus P. So it's either 30% and 30% and 70%, or 50 and 50, or 60-40, or 10% and 90%, something like that. And so we go through and we say, okay, if the productivity of the two workers is different, then the average marginal productivity of all workers is going to be somewhere between 1 and 2, and it's going to be a function of that probability. The higher the probability that workers are type L, the lower the wages we expect. But no matter what, because that proportion is going to be somewhere between 0 and 1, that wage is going to be 2 minus something between 0 and 1. And so low productivity workers will make more than they're worth, and high productivity workers will make less. And one way to think about this, and this is kind of how we talked about it in class, is that the low productivity workers will kind of free ride on the productivity of the type H workers. And so basically, without a signal, everyone gets paid the same amount regardless of their productivity. Type L makes more and type H makes less relative to what they actually do. So we need a signal that will prove which type of workers should get paid more. And in this case, in the model, we're going to say that there is a cost of education that is inversely related to productivity. And that's because otherwise type H workers are going to leave the marketplace, right? They're being harmed by that average productivity rate. And so they don't want to work in that situation. And so what will emerge if E is this thing, this level of education, so we can think about it as being a high school diploma or a bachelor's degree, if it's a signal, the signaling equilibrium occurs when the employer beliefs about worker productivity and the signal are accurate. And so the motivation for the signaling equilibrium is the employer's beliefs. So the employer believes that the productivity of workers is a function of E and then sets wages based on that. And then workers see the relationship between wages and E, the level of education, and then they make a decision about whether to invest. And that decision is going to confirm the employer's belief. And that's the big idea here, is that workers, even if workers just see E as a signal, the wage differential motivates their choice to go ahead and get that level of education, right? So I know I've heard people say this in class, right? I'm not here because I love economics and want to study it. I'm here because I'll get more money with a degree. That kind of is built into that. Okay, so getting E gets me the wage level that's associated with higher levels of productivity. For the model to remain in equilibrium, the employer can't see a signal that violates their beliefs, and that's important. So the signal has to remain valid. So that gives us what's called a separating equilibrium. And we talked about this last week, right? This idea that a separating equilibrium is a signaling equilibrium that separates high productivity workers from low productivity workers. And so out of the signaling equilibria, a separating equilibrium is one where different levels of schooling earn different wages. Employer beliefs are self-reinforcing. So when an employer sees a worker with high productivity that has that level of education, they're like, see, that's good. I should keep paying them more. And so the employer is going to tend to believe that type H workers get an education with a probability of 1, and that workers with E have a probability of 1 of being type H workers. And so it's sort of like the best case scenario in terms of being the signal being clear. So under which conditions would only type H workers get an education level E? It comes down to costs and benefits. It depends on the costs. So when education costs are lower for type H workers, which is one of our assumptions, and when the returns are high enough, when wages are high enough to make it worthwhile for them to go to school, to get that E level of education. So if the cost of obtaining E is C divided by 2, or half the cost for a low productivity worker, then the benefits have to outweigh the costs. So basically what we're saying is type H workers will invest in their education when C is less than 2, because the wages without an education are 1, the wages with an education are 2 minus the cost of the education. And we went through and did this mathematically together in class last Thursday. And this is called the incentive compatibility constraint. It says that a signaling equilibrium occurs where workers with different productivity levels get different levels of schooling and are thus paid different wages. So we can think about it in the contrary, and we can say, okay, well, type L workers will not invest in an education because the costs are going to tend to exceed the difference in wages. And so as long as the costs remain high relative to the difference in wages they can enjoy, 2 minus C being less than 1, then they're going to not invest in an education, and the separating equilibrium persists. And graphically, we can expect it to look like this. You can either get a wage of 1 or get an education level E and get a wage of 2. And so you can see this as being units of education. So maybe this is K through 12 and some college, and then here you get a bachelor's, and all of a sudden your wages jump up. If the cost of education is relatively high, like a type L worker, then the returns aren't going to be high enough to engage in education up to that point, and you'll be stuck at this equilibrium. But for a type H worker, the costs are low and the benefits are relatively high, and so they will be more likely to get that signal, confirm the beliefs of the employer, and then we get that separating equilibrium where type L workers don't have E and earn wage 1, and type H workers do have E and earn wage 2. The other situation, not a separating equilibrium, is a pooling equilibrium. And so we have signaling equilibriums. There's separating and pooling. Separating, H and L are separated. Pooling, are pooled together. A pooling equilibrium is a variation of a signaling equilibrium. This is where we left off, I believe, last time. And this is what happens when the cost of education is too low and all workers invest in the signal identically. And so you can see here, these cost curves for L and H are much lower. And so the benefits are higher for both types of workers. In this case, all workers, type L and type H, are pooled together. And the signal is what we call a noisy signal or an invalid signal, right? It's no longer going to tell an employer what kind of worker they're hiring. What we didn't get to talk about last time was an index. And an index is a characteristic about a worker that is not malleable, that cannot be changed. So remember we said, okay, a signal is malleable, it can be changed. You can put on a suit. You can get an education. Things like race, gender, ethnicity, those are called indices or an index. And it's still a worker characteristic, but it can't be changed easily. And employers might still have beliefs about indices in the same way they have beliefs about signals. They might believe that people who wear suits are more productive, or that women are less productive, or something like that, right? They might believe that productivity is tied to race or ethnicity. And so if employers have different beliefs about what the E signal means for different groups, that's going to alter the model completely. And that makes sense. That's a much richer, more realistic version of this model, right? Now we're taking it out of the textbook and putting it a little bit closer to the real world, where it's not just about your education. Other factors, some of which you can't change, alter the way you're perceived in the labor market. So if the signal provides different information to employers for different groups, there's going to be a difference in the incentive. So what we're saying here is if an employer has beliefs about the index characteristics that a person might have, they might change their beliefs about the signal characteristic. And if the signal isn't as strong, that's going to alter the incentive for that group to get the education. Does that kind of make sense? So one way to think about it is it used to be in like the 50s and 60s, women went to college to get a husband. And so the education signal wasn't that they're a more productive worker, it's that they went to college to learn typing or something like that. And so the E signal for a man, wow, he's ready to work. The E signal for a woman, oh wow, she's probably married and about to have a baby. And so employers would give different wage premiums for that same signal to those two groups with those two different index values. As an example, for instance, we can think about the modern era and how race and education intersect and interact, and how employer beliefs might change the perception of what education means for a Black worker, a Latinx worker, a white worker, Asian worker, or something like that. So the reality is that an index can alter the returns to education and alter the human capital model. Distinguishing between human capital and signaling models seems important, but they're not mutually exclusive. And a lot of people, including me, think that they probably coexist at least to a certain extent. There are two main reasons that it is useful to know whether human capital or signaling models are relevant, to know which is happening, to try and determine which has the stronger force. One is that in the signaling model, all the returns to education are private. So you get an education, you get higher wages, end of story. in the human capital model, the returns to education are not just private. There's also social benefits, or what the book calls the society at large benefits. And so that's important for our understanding of whether or not to subsidize education. The second thing is that under the human capital model, it matters how we produce education, because the better the education, the better quality of human capital, the better downstream benefits. Whereas in the signaling model, we could just be making stickers all day and it doesn't matter because it's just about getting the signal. And so it doesn't matter the quality or the kind of education being received or achieved. It's not really about what you learn, it's just about checking the boxes. And so those are the two main reasons why we want to distinguish between human capital and signaling, whether or not there's a social benefit, and also whether or not we care about how we educate people. So the first one speaks to this idea of private returns and social returns. The private returns we're familiar with. Education gives you higher wages, better job opportunities, etc., etc. It's what we talked about in both models so far. The social returns are the positive externality effects of education. So being a better person, lower crime rates, more social engagement, more entrepreneurship, more innovation. Those are benefits that accrue to society at large, not just the individual. And the positive externalities associated with education are the main rationale for government intervention and subsidizing of education. And basically the idea is, if there's just a marginal private rate of return and a marginal cost of education, then this first equilibrium prevails. And that's what we'd call the market equilibrium or the private equilibrium. But if there's also a marginal social rate of return, which you can think about as being the positive externality, right, the social benefit associated with education, then we want to produce more education. We need more education to get to this socially optimal equilibrium. And so the book uses a little bit different terminology with the rate of return, but really we're just talking about a simple positive externality model of education. Does that make sense? So basically there's the private returns, the private equilibrium, but those are lower than the socially optimal equilibrium and the social returns. And that's why we subsidize it. We want more education. And we believe that that's true for K through 12. The trade-offs get more confusing as we get further along in the educational world, I think. So in this case, individuals are going to tend to underinvest, and the government can subsidize education in order to get us to the socially optimal quantity. So, which prevails? Empirically, we've got a bajillion studies looking at whether the human capital model or the signaling model of education is the most relevant. There are a lot of studies that look at obtaining a high school diploma and like basically the education right before and the education right after, looking at higher education, like marginal value of education before, after, and during getting a degree. And so we'll look at a handful of the cases. There are more cases in the book. There are more empirical studies in the world. This is just a sample of some of the big ones. The first one we're going to talk about is Hungerford and Solon. And in 1987, they looked at men from ages 25 to 64 and looked at the marginal benefit of each year of education, the marginal rate of return for each year of education, and then articulated the diploma year. So like first year of college, second year of college, third year of college, fourth year of college, if you get a diploma, or fifth year of college, you get a diploma, what's the rate of return? And does it change significantly? And so we can look here at the percentage change in earnings as we go through years of schooling. And basically they see there is a spike in diploma years relative to non-diploma years. So we can think about the percentage change in earnings in year 4 relative to years 1, 2, and 3. We can think about maybe this is a master's degree, something like that. And this is what's called the sheepskin effect, the phenomenon where we see a return to a year of education on the margin is greater when that year includes a degree award. So basically it's saying each year of education is not the same. A year of education where you get a diploma is way more valuable than a year of education when you don't get a diploma. So basically Hungerford and Solon are finding that maybe there's a human capital effect, but there's definitely a signaling effect because having the diploma is more important than the previous years of education. Clark and Martriell in 2014 looked at basically the same kind of data, but in this case what they're looking at is earnings for individuals passing the GED. And so if you don't know, the GED is a test you take if you don't graduate high school, and it gives you a high school diploma equivalent. But your scores can be up at or above a certain threshold to get a GED. If your scores are below, you just didn't make it. And so they look at the earnings for individuals right after their GED and then on up to 7 to 11 and 11 plus years after they took the GED exam, comparing people just below the cutoff to people just above the cutoff. And we can see it's pretty continuous here. The continuous nature of the earnings shows there's not a huge diploma premium, right? The difference between the earnings of somebody who got 5 points less or 5 points more than the GED cutoff to give you a diploma equivalent, there's not a huge difference in year earnings. We do see the slope get steeper over time. So maybe there is a human capital effect down the road, but especially in these first 3 years, that line is almost flat. There's not much difference. And we could talk about what that might mean and how a GED is different from a high school diploma. But what this shows us is that this implies more of a human capital model of education. And so what we want to take away from this is that the empirical evidence is not certain. There is evidence on both sides, and probably both are true.